This is our final project proposal that we named KiwiBot, and it is by Uriel Perez, Freddie Serrato, Sarah Rose, and Sumer Ajam. Both the video links and the drive links are included in the presentation.
For our project, we'll be building a 3-wheeled robot using the Omni wheel so that it'll be able to turn in any direction and so that it can rotate about its own axis. This will make it easier for the robot to navigate the maze. Obstacle detection sensors will be placed on each side of the robot so that the robot will be able to see the walls of the maze and make decisions based off of that. Since each wheel is connected to a motor, each motor will have to be programmed, and kinematics will be used to figure out what motors need to be on in order to get it to move in each direction. Mounted to the chassis, we'll have a mechanism that can pick up the block, move it upwards, and place it onto the shelf. The part that will actually pick up the block is the servo motor operated claw. The servo motor will be used to open and close the claw so that it can clamp onto the block. And then a vertical gantry will be used to move the entire block and claw up and down. In order to keep the block out of the way while moving the robot around, the claw itself will rotate back so that it becomes vertical and the block will be on top of the robot instead of in front of the robot.
As for our plan of execution, we are splitting this into 3 different parts: the mechanical, the electrical, and the computer. For the mechanical portion, we would like to plan the design and the mechanism of the robot, meaning how it will avoid these obstacles, how it will detect that it's facing the wall, and how it will pick up these objects. We'd also like to initialize this design by assembling the chassis of the robot, and then finalizing with fully assembling the robot, including the arm and all that stuff being combined together. As for the electrical portion, we are planning the total amount of motors being used, as well as the sensors and actuators. This can also be seen in the computer section. We're also trying to connect all the electrical components and test the components to make sure that they are receiving signals and voltage across each sensor. We're also trying to finally integrate the motors into the mechanical design, as it can be seen as it closely aligns to the full assembly of the robot. As for the computer section, we are planning the total amount of sensors and actuators being used. Which was mentioned previously. We're also trying to program these sensors and actuators and test the components to make sure that they do function according to what we programmed them to do. Finally, we're also trying to integrate these sensors and actuators into the mechanical design. And to top things off, we will be 3D modeling this in SolidWorks. So here we can see the distribution of work. I will be in charge of the integrating of the motors into the mechanical design, as well as the sensors and actuators. I will also be modeling our design into SolidWorks. Freddie will be in charge of planning the amount of motors being used in our system, as well as connecting all the electrical components and as well as testing them to make sure that they work. As for Sarah, she will be in charge of planning and designing the mechanism of the robot itself, as well as the full assembly of the robot. As for Sumer, he will be assembling the chassis of the robot, planning the amount of sensors and actuators that we'll be using for this project, as well as programming them to make sure that they work correctly.
Now for our project timeline, starting with the mechanical, on the first week, Sarah will be planning the design and the mechanism of the robot. Simultaneously, the assembly of the chassis of the robot will be performed by Sumer. Following this, the full assembly of the robot will be done by Sarah until the 25th. For our electrical components, on the first week, the total amount of motors will be planned by Freddie. He will then connect all the electrical components and test these components from the 13th to the 17th. Uriel will also be integrating the motors into the mechanical design from the 15th to the 25th. For our computer programming section, on the first week, Sumer will be planning the total number of sensors and actuators we will be using. He will then program the sensors and actuators as well as test these components from the 15th to the 21st. Following this, Uriel will integrate the sensors and actuators into the mechanical robot from the 21st to the 25th. And Uriel finally will be doing the 3D modeling in SOLIDWORKS from the 7th until the 20th. Our expected outcomes for this project is that the robot will be able to autonomously travel through the maze to pick up said objects. The robot must be able to recognize when the object is in front of it. The robot must be able to pick up the object and take it back to the designated location based on the color coding. Following this, the robot will have to repeat the cycle by returning into the maze.